Hello and welcome to this video. We're going to look at the difference between a permutation and a combination. We're going to do that by both doing a permutation and a combination problem with these four little guys, all different colors. In a combination question, if you have 4C3, what it's asking you is from four distinct objects. Choose three. And don't worry about reordering them or putting them into positions or anything like that. Just in how many different ways can I select three volunteers, let's say, from four people. So I'm going to actually work through here all the different ways we can do this. So I could select blue, green, and red. That's one way I could do the selection. I could select blue, green, and yellow. I could select green, red, and yellow. And I could select blue, red, and yellow. So from the four people we had available, there are four different ways that we could go about selecting three of them. Again, the reason this is a combination problem is because you're just selecting them. You're not assigning them to roles. You're not making them president, vice president, treasurer. You're not putting them in seats in a row at a movie theater. You're only selecting people for whatever purpose. On the flip side of that is a permutation. If you have 4P3, you're looking at four distinct objects, and you want to not only select three of those objects, but you want to count the number of ways you could rearrange those objects once you've selected them. So let's look at our same four groups we had. If we select blue, green, and red, the same as our first selection we had here. That would count as one selection for a permutation, but the permutation would also count all the ways you could reorder the order these guys are standing in. So it would count blue, red, green as another permutation of how they could be ordered. It could count green, blue, red as another permutation. It could count green, red, blue is another permutation, and it could count red, green, blue is another, and finally red, blue, and green. So you can see from the one selection of these three people, there are six different ways that these people could be ordered. So if they were going to become, let's say, for example, president, vice president, and secretary, there are six different ways that those three people could be assigned to those three roles. Or if they were to sit in the first, second, and third seat in a movie theater, there are six different ways that they could sit down in the movie theater. That hasn't completed the question, though. That has just permuted one of my selections of people. In order to complete this question, I'm just going to quickly erase this. Oops. Sorry, guys. We'd have to go with another selection and go through this whole process again. So let's try that out. My next selection, we'll use this one, was picking blue, green, and yellow. So if I pick blue, green, and yellow, how many ways do you think I could rearrange them? We could rearrange these three guys six different ways. Let's try these ones. We got blue, green, yellow. We could do blue, yellow, green is another order. We could do yellow, blue, green. We could do yellow, green, oops, sorry little guy, blue. We could do green, blue, yellow, and finish up with green, yellow, and blue. Note again that with these three people selected, there are 6 ways to rearrange them once they've been selected, same as this group. So we're looking at having 6 times more arrangements than we do in just a combination. Now if I quickly finish this off, and I'm going to jump the video till where I've got this finished off, so please be patient, and I'll snap right back with this one finished off. As you can see, things got really cramped on the permutation side. On the combination side, we had 4 combinations. From 4 people, choose 3. We had 4 ways we could choose 3 people to volunteer for something. Doing a permutation, from 4 people, choose 3 to be permuted into positions. We have 24 ways, 6, 6, 6, and 6, to both select 3 people and then reassign them into positions or roles. And that is the key difference between a permutation and a combination. On the next slide, I'm just going to show you how this works out with the calculation of a permutation and a combination. Your teacher has probably already shown you the formula NPR is equal to n factorial over n minus r factorial. So in 4 pick 3, we would have 4 factorial. If you haven't done factorials in your class yet, I would suggest waiting till you get there and then coming back to this video. You get 4 factorial over 4 minus 3 factorial is 4 factorial over 1 factorial, which if you type it into your calculator works out to be 24. And as you saw on the previous slide, there were 24 different ways of selecting 3 people and then rearranging them into roles or positions. A combination formula, NCR, looks very similar to the permutation formula, except after your n and n minus r factorial, there's an extra r factorial in the denominator. And what that does is it actually cancels out the rearrangement of the people. They take the permutation and they cancel the rearranging out of the count. So we get 4 factorial over 4 minus 3 factorial times 3 factorial. 3 factorial is 6, if you check it on your calculator. And again, 6 was the number of ways we were able to rearrange these guys once we had them selected. That's what they're dividing out, is the number of ways that each of these groups were rearranged, trying to leave us with just the selection part and not the rearrangement part. What we end up getting is 4 factorial over 1 factorial 3 factorial, which simplifies to just 4, which again, if we look at the previous slide, there was 4 groups of people that could be selected, 4 groups of 3 people that could be selected from the initial 4 people. Now, as the numbers get bigger, especially with permutations, your number of ways things can be permuted gets much larger. It gets harder and harder to show with a picture the difference between a permutation and a combination. But you want to keep in mind, and in summary, a combination counts only the selection of the objects. So you select some number of objects out of some group of distinct objects. A combination does not count the reordering of those objects, whereas a permutation counts both the selection of the objects and then reordering those objects once they've been selected into roles like president, vice president, secretary, or into positions like seats in a movie theater row. Thanks for watching the video.